Resistance is a property of material, resistor is a device. So which is opposite flow of electron or which is restrict flow of current, that will be we are called as a resistor and the resistivity. So those are the properties we will discuss. Then after we discuss about different types of resistors available. So what are the types of resistors can be available? So those things will be we are discussed. Means those are the classifications of resistors we will be discussed. Fixed resistors and variable resistors will be there. So again subdivision also we are discussed. Then after the important topic, it is a color coding of resistors. Carbon composition resistors are very smaller in size. So because of that reason, color coding will be we are used. So that is authorized by means of EIA, Electronic Industries Association. So they are standardized the colors for coding the resistance value. So if it is a larger type, we can easily print the resistance value on surface of the resistor. So but in case of carbon composition material, it is not possible to print the value on surface of resistor. So that's why the color coding will be needed. So this is a tabular diagram. We know the formula for color coding. BB Roy, Great Britain, very good point. Right? So this is the order 0 to 9. We are taking the numerals for the color coding, and we have the tolerances as the 3 colors: gold, silver, and other colors, or no color also we are considered. Pink we are using for high stability application. So there are 2 types of resistors we have, that is a 4-band resistor and a 5-band resistors. Generally we are using. There are 6-band resistors also is there, and the last band is indicate the temperature coefficient. So if it is 4-band, the right halfmost we are considering as a tolerance, the rest of is the multiplier and the disease. If we are taking the 5-band resistor, the least one is the tolerance and the second left right one is the multiplier, the remaining 3 are the digits. So in case of 6-band resistor, the least one of right hand side we are considering as a temperature coefficient. The next second one is the tolerance, next third one is the multiplier, the rest of 3 are the digits. So based on that we have solved some problems related to find out the resistance value as well as colors also. If is given the color, we are find out the resistance value. If is given the resistance value, we are find out the colors of the resistor. So those things will be we have discussed. Next we discuss about common faults in a resistor. There are 8 faults will be there. So these are the common faults we have discussed. Next classifications of wire wound resistors. So they are classified into basically 2 types, then after divided into 3 types. Based on power rating, low, medium and high power ratings they are classified. Next we see about detailed construction of wire wound resistors, how they are constructed, what are the material we are used, so how the construction will be take place, what is the need and applications of wire wound resistors we are discussing. So a ceramic tube will be we are used to place the nichrome wire which is offer high temperature coefficient as well as high resistance as compared with the nominal material. So it can be withstand for higher voltages also. Because of these all properties, mostly for higher stability applications, wire wound resistors will be we are used. But it is not economical. Right? Size also is greater. So these are the specifications and applications of wire wound resistors. It is up to the fixed resistors only. Then after we discuss about variable resistors. Variable resistors are divided into 2 types, potentiometers and rheostats. The rest of things will be there. So we see about what is the potentiometer as well as different parameters of the resistor. Next we see about symbolic representation. Then after we discuss about types of potentiometers. They are divided into 2 types, carbon potentiometer and wire wound potentiometer. So this is a representation of carbon potentiometer. These are the representation of wire wound potentiometer. Just the resistance offered is increases as well as stability point of view. So we are using. So major difference between fixed resistor and variable resistor, additional terminal will be available. Additional terminal will be available. Right. So is
Prashant sir, Prashant.
Prashant. Right. So this is a basic difference between fixed resistors and variable resistors. Right. Then we discuss about LDR is nothing but light dependent resistor. So it is working on the principle of light intensity. So mean intensity may decreases, resistance value increases, intensity will be decreases, resistance value will be increased. Means inversely proportional relationship can be followed. So the value of resistance can be depending upon the light intensity. So where we are used also, we discuss automatic controlling system, sensing elements, automatic street lights. These are all the basic applications of the LDR. So this is a representation of LDR, symbolic representation, a zigzag line, and its arrow marks will be, we are put towards the resistive, so that is indicate the LDR. Then we discuss about the VDRs also. VDR is nothing but voltage dependent resistor. The value of resistance can be depending upon the voltage only. If the voltages we are given is a minimum, the value of resistance is maximum. If the value of voltage is maximum, then the value of resistance can be minimum. So this is a phenomena we have followed for the VDR. Right? So these are the construction features and the VI characteristics of the varistor. VDR also we are called as a varistor. So applications also we have seen. Then we solve the sum of the problem related to that. Then we discuss about specific resistance and conductivity. So we see the two definitions: resistance, specific resistance. Next, conductivity, specific conductivity. So these two will be we are discussing. Resistance is nothing but property of substance which opposes the flow of electric current, that is we are called as the resistance. Specific resistance is nothing but for a cubic area or unit area. So what is the resistance is offered, that is we are called as a specific resistance. So initially we are using the formula as R is equal to rho into L by A. Next, conductance, it is a reciprocal of resistance. Conductivity is a reciprocal of resistivity. Right. So these are the formulas we are using for conductivity as well as a conductance. So that then we find out the relationship between resistance and rest of things. Generally, it is directly proportional to length, inversely proportional to area, and directly proportional to the resistivity of material. So these are the basic concepts we have learned. Then we see about the numerical problems related to find out the resistance value, resistivity, and those things will be we have discussed. Next, we discuss about the temperature effect on resistance, or effect of temperature on resistance. So we see for metals, alloys, and insulators and semiconductors. Metals and alloys having the positive temperature coefficient. Next, insulators and semiconductors having the negative temperature coefficient. Is nothing but, in case of metal, the temperature will be increases, resistance value also increases. Alloys also follow the same. Temperature increases, resistance value increases. If temperature decreases, resistance value also decreases. But in case of insulators and semiconductors, if the temperature is increases, resistance value decreases. If temperature is decreases, resistance value increases. So these are the major factors we discussed. This is about graphical representation for temperature effect of resistance for insulators, semiconductors, conductors, and alloys also we have discussed. That is, next we solve for the expression for the temperature coefficient, that is alpha naught. This is the formula we are using, RT minus R0 by R0 into T. So from that we can derive a simple expression for any temperature also. So this is the formula we are using. Alpha naught is equal to RT minus R naught by R naught into T. So sometimes there is a need to find out the relationship between two temperature relations. That is the R1 and R2 for temperatures of alpha 1, T1 and T2. So this is the formula we are using. R2 by R1 is equal to 1 plus alpha naught of T2 minus T1. Only we want to find out R2 value, R1 of 1 plus alpha naught T2 minus T1. So these are the formulas we are using to calculate the resistance values for different temperature application. So we see the problems related to that. One case we are find out the R2 value. Some cases we are find out the temperature coefficient alpha naught value. So these are the problems we are discussing. Then after we see about resistors connected in series and parallel. So why we are connected is nothing but already we know that to reduce the voltage and currents in a given circuit, the combination of series and parallel resistances will be essential. So because of that reason, we are using series and parallel connection. So from the diagram we can understand the second end of first resistor is connected to first end of another resistor. So the sequence we are followed, that is we are called as a series connection. So we derive a small expression for the series connection. For 3 resistor, RT is equal to R1 plus R2 plus R3. For n resistors, R1 plus R2 up to so on Rn. That is the formula we are using for series connection. Already we know the basic things related to series connection. Voltage is divisible, current is constant. Next we discuss about parallel connection. If there are 3 resistors connected in parallel, the current is divisible, voltage is constant. The formula we are using 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 for 3 resistors. For n resistor, 1 by R1 plus 1 by R2 plus 1 by R3 up to so on 1 by Rn. So these are the two formulas we are using. So at the same time we discuss about if for example 2 resistors are connected in parallel to determine R equivalent. So R1 R2 by R1 plus R2. So that is the one of the formula we are using for 2 resistors. For 3 resistors, the product of 3 resistors by the product of adjacent resistors can be we are taken. So R1 R2 R3 by R1 R3 plus R1 R3 R2 R1 R3 R4. Right? So in this sequence we are followed for 3 resistors. So mostly we are getting only for the 2 resistors. Then after we discuss about combination of series and parallel connection of resistors. How can we simplify? So from that how can we determine the voltage values and current values for a given problem. So this is for the series connection. In this case we discuss about determine the individual voltage drop across each resistor. Then we determine the current. In case of parallel connection, the current is divisible. If you want to calculate total current, there are 2 methods we are using. Individual current calculations will be done, or directly we can simplify the circuit into a single equivalent circuit. Then we are find out the current value. That is the one of the methods we are using. So in case of to determine in a single branch current, these are the formula we are using. Means for current calculation, total current into opposite resistance by total resistance will be we are considered. This is for the current. For voltage, we are taking the formula as Vt is equal to V total into same resistance by total resistance. So these are the 2 formulas we are using to calculate the current values and voltage values in a particular branch. So in case of series, voltage formula we are using. In case of parallel, current formula can be used. So this is the syllabus up to last class we are discussing. So now today we will discuss about the 3rd chapter. So that is the electrostatic and electromagnetism. So first chapter is the basics completely. We discuss about atomic structure and then we discuss about differences between AC and DC, what is power, what is current, what is energy. Those things will be discussed in the first chapter. So next 2nd chapter completely we discuss about only the resistors. So from the 3rd chapter, so we can focus on the area. So last 6th chapter it is a very simple, 5th also it is related to the 3rd chapter. If we can understand the 3rd chapter, we can easily analyze the 4th, 5th, 6th chapter also. So 4th chapter completely it is depending upon the 3rd chapter. So the electrostatic and the electromagnetic. So today we will discuss about 3rd chapter. So the title is electrostatic and electromagnetism. So these are the two concepts discovered by means of a scientist. So there is a Danish scientist. He is a physicist. His name is Hans Christian. Hans Christian. So he has invented two theories. That is a electromagnetic effect and electrostatic effect. So he observed, so whenever a current is passing through a conductor, a needle is placed near to that conductor, so which takes place deflection. So what he is observed is nothing but, so a current carrying conductor is chosen and a small needle is placed near to that conductor, not directly contact to the conductor. He placed near to the conductor. So then he observed the whatever needle is placed that starts deflecting. So then he observed, so there is a magnetism will be present in electrical energy. Up to that, before that, he is invented in 1819. In 1819. But before that, most of the cases, the permanent magnets they are used for magnetized energy to produce the electrical energy or any energy. So the permanent magnets will be they are used. But there is a major drawback with the permanent magnet, which occupies larger cross-section area for a given application. The size is more. We cannot compatible. So because of that reason, so only which one having the highest financial budget, then only they are using the permanent magnet. So that is a major drawback. At the same time, the availability of permanent magnet naturally is available. So it is very difficult. So there are a few mines will be available. There are only few mines are available for drilling the permanent magnet. So from a rock they are collecting, and if they are finishing, it will be acting as a magnet. Right? So that is a concept they are using in the olden days. But whenever Hans Christian is observed about electrical energy, so he done a experiment. He take a conductor and it connected to a electrical energy. It may be battery or whatever it may be. It may be AC or DC. Whatever the current is there. So he is applied so that conductor